Hi, Spring fans! This is Singapore's famous Changi Airport. It is widely and routinely ranked as the #1 most loved airport in the world. After all, Changi has everything. Well, almost everything. It's missing a nightclub, which is a pity because it really could use one. I've spent way too many nights transiting through Singapore, and a nightclub would be nice. And you know what? They even have a really nice nightclub in Singapore called Zouk, which is a great discotheque or nightclub that, I think they could connect. I think they could install a 20-kilometer travelator from the airport to the club and then back again, and that would be great. This airport has to have everything because it has some very discerning patrons. The country of Singapore is so teensy-weensy, itty-bitty that every flight out of Changi Airport is an international flight. There are no domestic flights and no domestic terminals. Singapore is also a major hub of commerce in Southeast Asia. 1 out of 21 people there is a millionaire. That's a higher rate than in the United States. You've seen Crazy Rich Asians, haven't you? Singapore is a very international, cosmopolitan, and business-friendly city-state, and its airport reflects that jet-setter economy. So the airport has everything. Everything. You could take a guided tour, go into the city. Maybe you could just skip the guided tour, plan your layover accordingly, spend the night there, and go to Zouk. Did I mention Zouk's pretty cool? You should go to Zouk. If you're staying in the airport, there's shopping. So much shopping for everything, from salted eggs to Hermes to everything, right? Changi has you covered. But none of this tells the big picture of why it's so loved, right? I think it helps, and I think it would be more loved if it had a nightclub. But it doesn't explain why it's already so revered. You enter the building, then you clear immigration, and then that's it. That's where the similarities end. At this point, you've gone through a mostly automatic immigration process, and now you're inside the airport, but you're not behind security. And this is an important part here. The security happens later. Security is one of the parts where people spend a lot of time in their time at the airport, and as a result, they waste a lot of time. So security is one of those things where they've delayed that to the last possible minute. This is in stark contrast to most airports where security takes forever. Just see, for example, Chicago's ORD airport, Atlanta's ATL airport, New Jersey's EWR airport, London Heathrow. These airports are a nightmare to navigate if you are pressed for time. When you're ready, you go to your gate, leaving, of course, just a little bit more time than you normally would inside of an airport because here you're going to have to clear security. Now, this is okay. The queue depth, the number of people that are in front of you in the security lines are going to be very small because they are at most equal to the number of passengers that have to board the 1 or maybe on occasion 2 flights that are boarding from any one given gate. So each gate in Changi Airport has its own security machinery and its own security staff, and it has its own processes to manage that. This is expensive for an airport because it's redundant infrastructure. And yet the result is that when people pass through there, when people have to get something through the airport and onward, it goes by a lot quicker. So the clock time, the start to finish time, is a lot quicker than most other airports. The reason it's so much quicker than other airports is because in a traditional airport, security is in a single place. It's centralized, and everybody in the airport must funnel through that security. That means that the queue depth might be equal to, as many people as are about to board a flight in the next couple hours as the airport can accommodate. That means that you could be in that queue for a long time. This is an obvious application of the theory of constraints. We're parallelizing the work. Parallelization requires considerably more resources, but shortens the end-to-end passenger experience. So in conclusion, this is why microservices are awesome. So, we good? We're clear? I mean, you understand, right? It's the airport infrastructure, centralized monolith. It's all clear. Right? We straight? We good? No? No, you're a little confused. Okay, well, what I mean by that is that microservices are small, singly focused, independently deployable, bounded contexts. There are many work queues involved in developing software. Microservices are like Tamagotchis. They require a lot of work. Some work queues grow with the size of the changes to a codebase, while others can be parallelized and as a result can be done with just more resources, but in less time. Coding and testing individual features can and ought to be parallelized. The individual teams you have working on microservices can deploy concurrently. The more the concurrency, the shorter the wall time from having an idea and seeing that whole thing delivered into production. This assumes that people, of course, are able to develop and contribute to a code base while keeping the integration surface area to a minimum. The Moduliths project aims to help people build modular monolithic applications. Spring Framework tries to support loose coupling between modules in a code base in as many different ways as possible. There are so many to mention, but one is application context events, which allows you to publish asynchronous events from one component in an application context to another without them being aware of the producer or the consumer. Another feature that is very convenient is the really relaxed approach to package privacy. So you can have components that participate in the application context even though they're only just package private. This means that at compile time there's no type visibility, there's no exporting of types. Another thing that makes it really convenient for this kind of work is that it makes it very easy to write interface-driven code and then work in terms of those interfaces. So you can dereference service implementations and test implementations and so on by a common interface. Then comes integration. Invariably, after all the individual features are developed and working in isolation, they need to be integrated. And this work, depending on the nature of the work, can take a little bit of time or a long time, but whatever it is, it's going to be serialized work. It's going to be work that gets done as all the other things have wrapped up, and only as all the other things have wrapped up. The only cost, of course, is the redundant Changi Airport-like infrastructure that needs to be maintained for every single microservice. Like I said, they're kind of like Tamagotchis. When you're building a monolith, there are things that you need to only think about once in a blue moon that end up being a more common fixture in the work that you have to do when you start moving to microservices. When you build a monolith, there's work that you have to do, but you only have to do it once in a blue moon. Things like application security, JWT, OIDC, SAML, who knows? Definitely don't use their username and password. If you do that, Spring Security Lead Rob Winch will be sad. Don't make Rob Winch sad. Things like routing and standing up a database and message queues. Things like virtual machines and containers and hardware. Things like observability, routing, load balancing, compression, rate limiting, etc. There are some solutions to this problem, however. My friend Chris Richardson wrote a great book called Microservices Patterns for Manning, and in that book he talks about a pattern called a service chassis. A service chassis is basically Spring Boot, right? It's a framework that optimizes with as few configuration properties as possible the process of setting up all this stuff, all these things that the framework can do while containing your Java code. So the service chassis is going to make as trivial as possible the work of setting up authentication and setting up routing and setting up whatever, right? But it's still redundant, right? You still have to do it for each microservice. And hopefully you've got some auto configuration, some Spring Boot starters to reduce that configuration and to centralize it so you can just redeploy that. But it's still going to be manifest in every single application that's been deployed, right? Every single one will have at runtime all these concerns in the code base itself. So at runtime, the deployed module is larger in terms of the things that are running in memory, but cognitively it costs the developer a lot less than it would otherwise, especially when amortized over all the possible applications that have been deployed, right? If it's just one, then sure, figuring out all that stuff and making it work correctly is a lot of work. But if you've got a recipe for it and you don't need to do anything the second time you've used it, you just plug in the relevant and extremely minimal properties to get it working, that's great, right? That's a cost win. That's a gain. That's a profit. An API gateway like Spring Cloud Gateway is a great way to re-centralize some of these concerns. API gateways work because they're minimally invasive. We don't have the cost of integration that we have to worry about because it's just a few touch point properties. There's no code, there's no involvement in the business logic, or if there is, it's minimal and you can express it in terms of an interface, again, because we promote decoupling, right? So the API gateway allows us to re-centralize some of this work and thus reuse some of that work across all of our services while reducing one of those serial queues, that of integration and integration testing, to as small as possible. This is the best of both worlds. Here, we get common cross-cutting kinds of concerns expressed in a single place, so we get our DRY principle, do not repeat yourself principle. I just repeated myself. And then we get individual microservices where the business logic, which is subject to change because different teams are working on it, can be deployed and evolved independent of other microservices. So you get the best of both worlds. You get to have your cake and eat it too. You know what an API gateway does not normally do? Notch ever closer to sentience. What is going on with this, Google? AI in your API gateway? I don't even know what that means. Suppose you're a developer and you want to connect your external clients to your backend array of services, but you need to handle things like CORS headers, or reject any unauthenticated requests, or you want to translate one protocol from another. This is an ideal use case for an API gateway. Axway.com is a great description of an API gateway. It describes it as code that sits in front of your APIs and that is a single entry point for all requests going into that system. It makes the point that microservices and APIs need to have consistent quality, and an API gateway can help ensure that high level of quality for things like compression, for things like security, rate limiting, caching, etc. Basically, API gateways and the service chassis pattern help us to clear up some of the costs, some of the redundancies implied by the move to distributed systems. I'm sure you're all well aware of what Spring Boot is, so this video is not going to be an introduction to Spring Boot itself. This video will be an introduction to a Spring Cloud Gateway. We made the move to microservices to get smaller, singly focused, independently deployable, bounded contexts, and to get autonomy, to get velocity, to get the ability to parallelize work, and to see that work released as often, as frequently as possible. Microservices give us organizational velocity, but it comes at a cost. There is some duplication of work, and Spring Cloud Gateway can help you eliminate those redundancies too. You can have your cake and eat it too if you embrace microservices and use an API gateway. And we will, on this episode of Spring Tips. All right, let's get started. We're going to build a brand new application that uses Spring Cloud Gateway. So we'll go, of course, to my second favorite place on the internet, start.spring.io. And there we're going to build a new application called Basics. And in this application, we're going to use the Spring Boot support for Spring Cloud Gateway. We're going to use the Spring Boot Actuator. And we'll use the Reactive Web support. Just for posterity, I might include Lombok. I'm not sure if I'll have time or reason to use it, but it never hurts just in case, right? With that, I'm pretty satisfied with my selections, so I'll hit Generate. This will give us a brand new project which I can open up in my IDE. All right, let's open this up in my IDE. And here, we're going to define a route locator. The contract for Spring Cloud Gateway is very clear. Just create a bean of type route locator and the application context, and Spring will pick it up. So, bean route locator. Return, and then of course to build these beans, we'll need a route locator builder. So, route locator builder, RLB, rlb.route.build. And we're going to have to create some routes. So we'll create a route spec dot path. And the idea here is that you create a route, and each route has three main components. And you can create, by the way, as many routes as you like. So I can chain these together. And each route spec has a predicate, and the predicate can be really anything, right? You can determine whether a request is allowed to go through based on the path, based on some headers that are present, based on the URI, based on the host and method, the HTTP verb or method as we call it, a custom query parameter present or not, or just generally, does it match a predicate or does it match the negation of that predicate, right? So you have a lot of different ways of writing these predicates. For our purposes, let's just start with something very simple like hello. Okay, so this is the path. When somebody makes a call to our service, our gateway service running on port 9999, we will match that request if the path is hello. And we're going to send this on to the spring.io guides page. Okay, now the problem is that each request that comes in is preserved and forwarded or proxied to the downstream service. Well, of course, in this case, the downstream service is spring.io, and there is no URI spring.io/hello. So we need to change this, and this is where the power of filters come in, right? Here we can create a filter to change the outgoing request. For example, to change it to guides. So let's go ahead and restart this now and see what we get. All right, so there's my brand new application. Let's go ahead and open this up in our browser. So localhost 9999 localhost 9999 /hello. And when we do that, you can see very clearly that we've gotten, the output from the guides page, building a RESTful web service. The styles are not working. I presume there's some sort of relative path that no longer works correctly because we're no longer on that host and port. But you can see it very clearly proxied the HTML markup from that downstream service, right? And I'm able to get it from here. You will see on occasion on my console that I have these exceptions related to the way that Nitty works on my machine. This doesn't actually seem to cause any issues, so you can feel free to ignore that. And by the way, you can give your routes an ID, right? So you can say, I'm going to have this be my Twitter route. And then you can configure the route spec like I did before. So here, route spec, and the path here is going to be Twitter. So anytime somebody sends us Twitter / @ and then a Twitter handle, we're going to preserve that, and we want to rewrite it. I actually want to keep that path, but rather than just changing it to something brand new, I want to apply a regular expression to extract out certain fragments of the path and then forward that onward. So we're going to use a filter spec, and here we'll say rewrite path Twitter @ and we're going to use a variable, basically. We're going to create a variable handle, and when we perceive that particular predicate, we want to send the request onward, and we're going to do that with a rewrite. So this is a very common thing. You've done this, no doubt, in something like Nginx or Apache mod rewrite or something like that. Okay, so there's our new path and our new spec. So path, filters, and then of course the downstream URI will be twitter.com. All right, so there's the rewrite. So we're taking the incoming request, we're extracting out the handle, and we're replacing it with just /. So it'll be twitter.com /. And actually, you know what? We can get rid of that. And save the user some pain. So it'll go to that URI. So let's go ahead and try this out. All right. So hello is working. Now what about our Twitter endpoint? Our Twitter endpoint relies on having a path called Twitter Starbucks man. And there you go. There's the output from Twitter itself, proxied through to the browser in the page there. And actually, you can see it's the Twitter markup itself has a redirect, and it determines if the host is actually anything besides itself, and it redirects to itself. So I proxied that page, loaded it in the browser, and I got redirected to Twitter. Now, suppose I tried doing that from my proxy, from the command line, where I don't have follow redirects enabled, and I do localhost 9999 /Twitter /Starbucksman -v, and you see what happened there originally. I got it moved permanently, and it said I should go to https twitter.com /Starbucksman, and that's what happened here. It redirected me to this. All right, so Spring Cloud Gateway, as you can see, just to demystify it, is just a gateway. It's just a proxy, and it can act on incoming requests through filters. So you have predicates, and the predicates can be multifaceted. You could have the path and the host, for example. You could say, if anything went to, if the host header is *.spring.io and the path is hello, and it's after, zone, date, time, now. So any request that comes into the service after the current, when the application starts up, then that'll get honored, for example. Or you could say, if I wanted to provide a custom predicate, I could do that as well. I could say async predicate, new async predicate, and here I'm given a chance to provide a test that's deferred. It's a reactive non-blocking test. So I can say, okay, well, server web exchange dot get attribute, foo, right? And so you can say return mono.just. In this case, the the non-blocking return value didn't really buy us much, but you can kind of see the opportunity there. Anything that returns a mono of Boolean, for example, you could have just called that to determine whether this request should be allowed to go through, for example. So there's our very, very simple filter. Okay, so we've got we got three different things going on there. We're saying, if that predicate is there, if the path is there, if the host is there, etc. Now, obviously, I don't have any attribute named foo, so let's just drop that for now. But really, these predicates are as flexible as you want them to be. You can customize it based on all sorts of different things there. You can negate, etc. Now, if we run this, we'll see what happens. Let's see what happens when we try and run this and we don't have the host header in place. Curl HTTP localhost 9999 / and then the endpoint there is hello. Okay, minus v, you can see it says 404 not found, but minus h host test.spring.io, and there's the JSON. In the output in the markup, you can see it proxied the request because it perceived that host headers in the body. One of the interesting opportunities here is that Spring Cloud Gateway works very nicely with all the observability tools that are in Spring Boot itself. It also provides Actuator endpoints. So you can see two different endpoints that are provided out of the box. Localhost 9999 / Actuator. You scroll down and you can see that there's a gateway endpoint here. And this gateway endpoint provides a routes sub-endpoint telling us what predicates are available and so on. It also provides us a metrics integration. And by metrics, I mean it integrates with Micrometer. Micrometer is the metrics collection abstraction that we use inside of Spring Boot to simplify the work of collecting different kinds of statistics. Things like how much CPU we have, how many requests per second we can make, etc. We can also use Micrometer to publish our metrics to another time series database, something like Grafana or Netflix's Atlas or Prometheus or whatever. You don't have to do anything except for have Actuator in the class path and opt into the metric, Spring Cloud. So here it says Spring Cloud Gateway metrics enabled equals true. So with those in place, we can visit Twitter, Starbucks Man, and localhost metrics, and you can see that there's a key there called Spring Cloud Gateway requests. Take that here, and you can see a breakdown of how many requests there have been, in this case 1, that the time total taken by the whole of the processing, the route URI, the route ID, the HTTP method, the outcome was a redirect, the status code that we got was moved permanently, the status code that we got was 301. All of this is visible inside of these metrics that you get for free out of the box just by using Spring Cloud Gateway. Now that we know what the basics of using Spring Cloud Gateway look like, let's stand up a service that we can then use in further demonstration of some of the more advanced features of Spring Cloud Gateway. We're going to go back to start.spring.io, and we're going to build a new application called Customers. And this is not going to be a gateway application, it's just going to be a reactive web application. It will eventually participate in service registration and discovery, so we'll use the Eureka discovery client support. All right, there's the application. Let's go ahead and just spin this up. UAO customers.zip. There's our brand new application. We can go ahead and make some changes, and this is just a simple example so that we have something with which to work in the balance of our demos. We're going to go ahead and pin this to a different service port, so let's say 8181, and we're going to give this a name to identify it to any service registry that we use. So we'll give this one the name Customers. Let's create some sample data of type customer. And it's just a DTO, so we're going to use Lumbach to create some getters and setters and some toString and some equals and hash code and all that good stuff. One will be an HTTP service and event stream based endpoint, and the other one will be a WebSocket endpoint. In order for this to work, we're going to need a reactive stream that produces updates to the values that we can then see trickle out in the WebSocket endpoint and in the service and event stream. So we'll go ahead and do that here. We'll create that bean, that reactive publisher that emits these values here. The job of this supplier is to return a new customer when asked. So I'm going to assume that we've got a, obviously I don't want to generate infinite data, so I'll just have a hard-coded list of names here, and we'll cycle through those names infinitely. All right. There's our names, and we're going to cycle through that by creating a counter. So private final atomic integer, counter equals new atomic integer. So the goal of that code is to read through the array, and every single read increment a counter, and then we're just reading through the array and getting the modulus. So the goal of that is to read every single value in the array and then just constantly keep updating it. But of course, we don't want to have, if we keep incrementing the number, it'll keep producing numbers that will eventually exceed the bounds of the array. So we're just modulusing the count. So that way we get a number that is always at most equal to either 0 or any number underneath the length of the array. Now we have a customer's publisher. Now we have our publisher, but what I want to do is I want to make it so that this publisher is delayed, so that the results that we get are themselves delayed. So I'm going to use duration of seconds, and I'll plug in, let's say, 3 seconds. So each element will take 3 seconds to arrive. Let's create a reactive stream at bean publisher of type customer, customers, return this dot customers dot publish dot auto connect. That way, if we have two different endpoints serving the same stream of data, they'll get the same number. So by the, let's say that the stream has been running for a minute and it's up to number whatever. I want to make sure that when I access that data from the WebSockets or from the service and event stream, that I get the same new numbers, right? Every number should be the same. It shouldn't restart the stream just because I've made another request. I want to get the same view of the data. So I'm going to publish it and auto-connect it. And now I've got a reactive stream, and I can then use that to create an HTTP endpoint and a WebSocket endpoint. So let's go ahead and create the WebSocket endpoint. So WebSocket configuration, and we'll create a bean, and the WebSocket handler is where the business logic will live. And so we need to tell Spring WebFlex to look for. So let's create a new endpoint that has the WebSocket logic. So WebSocket handler, return new WebSocket handler. And our job will be to take the data that comes from the publisher reactive stream, the customer reactive stream, and to turn it into a response. So we'll say customer flux.map. I'm going to take each customer, private string from customer, and we're going to use Jackson. And in order to use Jackson, we need to hold our nose a little bit and deal with the try-catch exceptions that get thrown for everything, and deal with the try-catch exceptions that get thrown everywhere. So we'll say return this.objectMapper.write value as string customer. And we'll use lumbuck to swallow that exception and return this here. Return map C customer from customer. Okay. Now, let's take each string that gets created for us and turn it into a WebSocket message. And let's take that whole thing and send that back. Session.send map. All right, that's the WebSocket handler. Now, of course, in order for this to work, we need a simple URL handler mapping, which is the bean that'll expose our WebSocket endpoint to the world, make it available, basically, routed. Map.of WS customers, WSH, and we're going to inject our WebSocket handler. And we're going to make sure that this has higher priority in the routing for our local application. Okay, so that's our WebSocket logic. We also need an HTTP endpoint, so let's do that here. We're going to create a REST controller, class customer REST controller. And, looking back, maybe I should name this customer WebSocket configuration. And we'll create an endpoint here. And this endpoint will be it'll produce a server-send event stream, and the path will be customers. Publisher of customer get return this dot. And then all we're going to do is we're going to inject that same stream, so private final. Publisher of customer. Okay. There's our updated endpoint, so we can try it out right now. You can see it's failing because it hasn't found a service registry in which to register. We'll tend to that in just a minute. Localhost / 8080 / no, it's localhost 8081 / customers. And so on. So this will just keep going. It'll keep going until it wraps around, and then we'll. At this point, hopefully you've got a sense of not just the core of Spring Cloud Gateway, but of its potential, right? You've got a sense of the lay of the land, some of the extension points, etc. And we're going to deep dive into those particular extension points and some of those more advanced features in the balance of our tutorial. But I figured in this situation, since we've got a sort of broad understanding of what's happening, now's a good time to then revisit why we have this technology, why we have Spring Cloud Gateway, why it's part of the Spring Cloud portfolio. And I asked my buddy, the one, the only, the amazing Spring Cloud co-founder and Spring Cloud Gateway creator, Spencer Gibb, to answer a few questions for me.
At a conference in Boulder, Colorado called DFRAG, and had listened to speakers like Brendan Burns, and I was just there as an attendee. Netflix had blogged about Zool 2, and lots of people were anxious because Zool 1 didn't do things like long-lived connections, and its API was fairly poor, and there were lots of statics, and it was difficult to integrate with. And as I was thinking about it and looking at the code, watching the development alongside of Webflux, the thought crossed in my mind that we could probably provide a better developer experience along with better features if we did it on our own. So, rather than having to adapt things like HTTP headers and all that stuff, we get that kind of stuff for free with Spring WebFlux. So I went ahead and built a proof of concept, with WebFlux to make sure that I wasn't crazy and could actually make requests. I even switched. I think I started using Web Client, but it wasn't fully featured enough, so I went to use Netty's HTTP client, that kind of thing. Built a proof of concept, decided, maybe I'm going to show this to a few folks, and wrote up a Google Doc and sent it to Dave Sire and Brian Dussault, and they were like, yeah, let's do this. And it turns out it was a great idea because they had to rewrite Zool 2, and it took more than a year for them to finally open source it. And I got all this great infrastructure from the Spring team, from Project Reactor, right, which is so much simpler to work with than RxJava, and all the way to WebFlux, right, and all the primitives that live there. And Gateway becomes predicates and filters over WebFlux, basically, and bridging those connections and being able to route based on anything in the request, whether that's host name or request parameters or headers, not just path. And that filters can be easily written on your own, right? They can just be a few lines and provide a much better developer experience for folks that want to customize their gateway. Sure. One of the top use cases is centralized security. When we talk to customers, that's one of their top use cases. Things like automated canary rollouts are another use case. You can embed Gateway in your applications and be able to overcome things like cross-origin requests, since you can forward, to services behind your single-page app or whatever you're doing. Edge kind of services, right? Just general proxying and load balancing, and automatic, kind of self configuring gateway when you plug into discovery services or something like config server or something like that, where you can just refresh routes and change configuration and get new, respond to challenges or new customers or new something fairly quickly with that.
In the last section, we briefly alluded to the possibility of using service registration and discovery with Spring Cloud Gateway. We added the Spring Cloud Starter Eureka Discovery client to the class path, intending to be able to talk to it at some point down the line. In this section, we're going to look at how to do that. We're going to stand up a Eureka service registry. Now, keep in mind, while I'm using Netflix's Eureka, which is a very, very popular, very easy to set up for a demo choice, it's not the only choice. There are other implementations of the Spring Cloud Discovery Client abstraction, supporting, among other things, Apache Zookeeper, HashiCorp Console, Kubernetes' labels and selectors-based DNS, and, of course, Cloud Foundry. And so while these are just the beginning, you can easily plug in others with that same abstraction, if you like, as well. We're going to create our own Eureka service registry by going to start.spring.io, and here we'll build a new application called registry, and we're going to add the Eureka Discovery Server dependency and hit generate, and then open this up in the IDE. So our application itself will be a Eureka server. And the application will listen on port 8761. We'll tell it not to register itself with itself. We'll tell it not to fetch the registry from itself. And we'll give it a name. Not that we need to, but it's just, it's just good habit. So we'll call this registry. And that's it. Let's go ahead and start this application up. Now we're going to need to talk to it from our customers application. So I'm going to go ahead and restart the customers application. When we started it last time, it failed because it couldn't find the service registry. So there's our customer's service. It's restarted. Let's go ahead and restart the customer service. When we started it last time, it failed because it couldn't find the service registry. So the application's up and running. Let's go to our browser and confirm as much by going to localhost 8761. There's our service registry. The Eureka console is all spun up and ready for us to use. And there's our single service with one instance at this host and port, that ID, etc. Now we can actually use this in our Spring Cloud Gateway code. I've got the Spring Cloud Gateway code that we created earlier here in a new project. I've just copied the old code. I've just renamed the project to Discovery. And we're going to go ahead and get rid of the Spring Cloud Gateway code from last time. And keep in mind, the Spring Cloud Gateway code doesn't have any awareness of the service registry just yet. So we need to add the Spring Cloud Starter Discovery client to the build, just like we did for the customer's build. So we'll go to the pom.xml, and we're going to copy and paste the Eureka Discovery client. Maven re-import. And so now we've got our Spring Cloud Gateway application. We can do some interesting things without writing a line of Java code. First things first, we can go here and we can do the locator. We can set up the Spring Cloud Discovery locator. We're going to enable that. Now that means that every single service that we've added to the service registry will have a route automatically in our gateway code. And in this case, it'll create it exactly as it appears here. The problem is that right now it's uppercase customers. So there's actually a very convenient thing you can specify here to lowercase it. So let's go ahead and restart this. We'll go to localhost 9999, and we can go to customers /customers. And there's the data. So I'm going to the edge service, I'm going to the gateway code, and the gateway code is forwarding the request to any service in the service registry called customers, and any path that we send after that service ID is being sent unchanged to the downstream service. All right, so there we go. There's our service registration and discovery integration out of the box. We might be done there. You might just want to do that and be done with it. You could send that, you could stand that service up and deploy it as your edge service and make it so that your clients could then talk to that via the HTTP APIs, and you might be done. However, we can go further. Let's create a gateway route that talks to the downstream service. We'll use the route locator builder as always. So gateway route locator builder RLB. We'll say rlb.route.build. Route spec, and the path here will just be customers, and the URI will be a load balanced URL, so load balanced to customers. Right? So LB is a custom schema and a scheme prefix that you can use that will tell Spring Cloud to interpret this host path, this host segment of the URI, as the service ID in the service registry. So that might be enough, right? You can just take the path and then forward it on to customers unchanged. In this case, it would get sent to customers / customers, and that might be exactly what you want. Okay, so if we go now to 9999 / customers, we get back the data being sent from the downstream service directly. So this is very convenient. This ability to do load balancing is very powerful. Behind the scenes, what's happening is it's using the Spring Cloud load balancer abstraction to, in client memory, decide which instance it should route the request to. You can plug in the abstraction or the algorithm that it uses for client-side load balancing. By default, it's going to do least recently used, but you could also do round robin. You could do all sorts of things. The other nice benefit of this is you don't have to set up DNS for the downstream service, right? As long as it's got a logical name, which is customers, it'll be in the service registry, and the service registry will map to an instance of that service. Even if you only have one instance, this is very convenient because you don't have to have magic strings around host names and the like in your source code, right? In your Java code, you can just use the logical name, and whatever host and port that service is found on will be resolved this way. Let's go ahead and shut down the customer service. Spring Cloud Gateway is aware of the service topology changes, and you can listen for an event related to that by creating an application listener. Refresh routes event. Routes refreshed. And here, we're going to listen for the event, and the event is the refresh routes event, so we can interrogate that. rre.getSource is an object, but we can cast that to a caching route locator. Like this. And that object has all the data. A publisher of routes. And we can then visit all that data. We can say we want to subscribe to that route. And once subscribed, we can print out the results, the updates. One thing that's kind of interesting here is that the discovery client discovered itself in the registry. So at some point, our host and port, our service, the gateway service itself, registered itself in the registry as unknown. You can change this application name by using spring.application name. And then eventually the heartbeat eventually detected that there was that new entry in the service registry. It pulled down the remote table of results, and now we can see there's 3 entries that are being printed out periodically by the heartbeat detection here in my refresh routes result event listener. So it discovered that entry there. The same goes in the opposite direction. If you were to disconnect something, it would also understand that eventually. This is very convenient because now we've got a very dynamic, sort of fluid way of building services. In this section, we're going to talk about how Spring Cloud Gateway interacts with configuration. The first thing you need to understand is that Spring Cloud Gateway is just, as always with all things Spring, just objects, right? And so we've been using this DSL, the route locator builder, to build our route locators. But that said, the contract for a route locator is really trivial. Have you seen the interface? It's just an interface with one method, and it returns a publisher of routes. Each route, in turn, is just a bunch of objects, most of which are strings and integers and primitives that you could easily come up with on your own. What may not be so obvious are some of these async predicate implementations, but of course there are implementations that we can use out of the box, and the gateway filter implementations, and again, there are implementations that we can use out of the box. The implication being that you can construct these routes any way you like. You can manually construct these routes if you like. So let's look at that in action. We're going to keep the routes refresh method from the last time, but let's go ahead and manually create a route locator. So we'll do that here. We're going to create a bean of type route locator. I'm going to call it gateway, just as last time. And this time, rather than using the route locator builder, we'll just write the code ourselves. It's not that big a deal. And it'll help, hopefully, give us some sense of what needs to be done. So we're going to create a single route. We'll say route.async. We're going to give it an ID, so test route. and then we're going to give it a async predicate. And here, the predicate could be, anything. Let's suppose that we want to decide, that we want to send a request to the downstream customer service, and we want to accept it if it says customers, but nothing else, right? So var URI equals exchange dot request dot URI, and the path, of course, is the URI dot path, and the match is, does the path contain customers? If it matches, then we keep it, right? So return mono.just match. And so this will match whether we ask for the service and event stream or the WebSocket stream. Okay, so that's the predicate there. That's easy. And the next thing that we want to do is we want to configure the URL that we want to send this to. So lb customers. Okay. And finally, we want to configure the filters. And here, we have to wrap the filters. So we say new ordered gateway filter. And then you can wrap any of the filters that are provided for you out of the box. And you can configure any of the ones that you want, but you have to use the factories, right? So set path gateway filter factory. Okay. And then we say ff dot, and then here we create some config. So config dot set template to be customers, right? And then so we've wrapped our filter and we've used the factory. We need to provide an order. That's the important bit here, is the ordered gateway filter. So we provide an order of 1, and that's it. That's a very simple route, but it does work. And then we build it, and then we just return a stream containing that one route. So all right, there we go. There's our basics application. Let's run it. Localhost 99 customers. And there we go. There's the data being sent from downstream. So we created a route manually, right? This isn't using the gateway route locator builder at all. It's just using the default objects underneath the hood, which you could do as well. And that's the important part here, is that the configuration is separate from the engine, right? So how you configure it isn't just the Java API or the Java DSL that I showed you. This has some interesting implications, one of which is that you can configure entire parts of your application using just the YAML or property-based configuration format. So let's take a look at that. Let's configure the application using the property-based DSL. I could use the .property syntax, but I think for this particular application, YAML might actually be the better fit. And I don't say that lightly. You know how big a fan of YAML I am, but we can use application.yaml and Spring Cloud Gateway routes. And then the first route is the guides. The predicate that we'll use includes path equals guides. And we're going to say that the request will only be valid after this time. And we can specify a time zone as well. Okay. So we have two predicates there. We're saying if the path is equal to guides and if it's after this time, then send it to this URL. Right? So this is a new route, and it's going to be picked up automatically when we restart the application. So let's go ahead and restart it now. Okay, so now when we start up, there's actually 3 different routes that have been registered automatically. And this one, of course, goes to spring.io/guides. So we can try it by going to /guides here in the browser. And you can see the output is as we expect. Now let's change this predicate to be something that's in the future, right? So 2024, which as of the recording in early 2021 is definitely in the future. So now there's a 404. It doesn't exist. It doesn't matter what time I, try, unless I'm willing to wait 3 more years. This isn't going to work. So that's one way. That's one benefit of this approach, is that you can store the configuration in the YAML file and in a YAML file. Now this has some very interesting implications. This means that we can use Spring Cloud Gateway as kind of like infrastructure. You can configure a lot of stuff. You can configure a lot of it using just YAML files. That's very powerful because you probably know that you can also, with Spring Boot, store configuration outside of the binary. So you can actually store this in a local file system, for example. You could store it in console. You could store it in the Spring Cloud Config Server. Now, the Spring Cloud Config Server is a centralized configuration registry. It contains all the configuration information for various services in the cluster. They all spin up and they connect to the Spring Cloud Config Server to read the configuration. It is based on Git as well, so you can have a Spring Cloud Config Server whose information is backed by a Git-based repository or a Subversion-based repository. It can be version controlled. It's auditable, so now you can see who made changes, when, and where. And the best part is, you can even have Spring Cloud Gateway dynamically reload its configuration based on those changes. So let's move this file, application.yaml, to a directory of configuration. cd desktop, make dir config, cd config, get init, touch application.yaml, and I'll open up this file and paste in all that in. So there's the predicate there. I'm going to do git add application.yaml, git status, git commit, initial commit. And now I've got a repository full of configuration. Let's spin up a new Spring Cloud config server by going to start.spring.io, and we're going to call this the configuration service. And we'll bring in the config server, Lumbuk, and that's it. Actually, I don't even know if we need that either. Let's just leave it like this. So, downloads, UAO configuration-service. All right, so we have got our config server. We just need to say enable config server, and in the properties, we'll go to port on 8888, and we're going to say that we want to point it to the URI of the configuration. So Spring Cloud config server.get.uri equals home desktop config. And you might, if you create a new Git repository on GitHub, remember that the default branch is no longer master, as it will probably be when I git init something on my local machine. It's going to be main for all sorts of very good reasons, right? And so for that, you need to make sure you specify the default label as main, okay? But for our purposes, since I initialized it using Git on my local machine, for the moment, it still defaults to master, so we'll just leave it there. And restart. So now microservices will connect to the Spring Cloud config server to read their configuration, and they'll hit an endpoint kind of like this one, and they'll get their configuration from there. So you can see that the configuration has been rewritten as an array. So it's this, if you're wondering how to express those routes using property file format, this is basically it, right? This automatically translates your YAML into a property format anyway. And we have a single route with an ID guides. The predicate is as such, and the second predicate is this way, is specified as here. And then here's the URL. It's the same information as before, so that means that we no longer need it in the actual gateway's repository. So let's delete it here. And we're going to enable the Spring Cloud config client to talk to the config server in our gateway application. So I'm going to go back to the Spring Initializer, and I'm going to get the config client dependency, and I'll copy and paste that into my build. And re-import. Now that we have the Spring Cloud Starter config client on the class path, let's go ahead and change our microservice so that we are identifying ourselves accordingly. Spring.application.name equals gateway. By default, if the microservice is named bar or foo, then the Spring Cloud config client will connect to the config server and get foo.properties and foo.yaml and read that into memory and then make that available as configuration. All microservices, no matter what their name, will see the configuration in application.properties or application.yaml. So I've renamed the microservice Spring application name equals gateway. It's going to pull in gateway.yaml, gateway.properties if they exist, and application.yaml and application.properties if they exist. And you may know that Spring Boot has an extensible configuration mechanism. Spring config import config server : right? So we can actually give it a URL if we wanted to, but by default it'll just use Spring Cloud config URI, which by default is equal to localhost 8888. So I specify that here, but it's redundant because that's what the default is. You can override that, of course. All we really need, the important bit, is that. That's what tells the client to participate in centralized configuration. If we restart the application thusly, we can see that we've got this endpoint here from the config server in our class path, right? And available here. So now, if we go to /guides, localhost 99 guides, there's our data again. It's working just fine. So now let's suppose I want to change the configuration to point to a different date. I can go to the config file. So let's go change the configuration to point to some other date in the far-flung future. I'll hit save, and then the command line, I'm going to commit that change into the Git repository. So git commit updated date. And then I'm going to trigger a refresh by using the refresh actuator endpoint. So I'll say curl -x post to HTTP. And now we can see on the command line, on the console, it says the route has been updated, and here's the new route. We didn't have to restart the Java application, and of course, if I hit this, it no longer works. So you can reload the configuration. You can externalize it, centralize it, and then reconfigure the application without having to redeploy the Spring Cloud Gateway code. In this way, it's acting more and more like infrastructure. You can actually write Java code that responds to these refresh events as well. You saw, of course, that you have this routes refreshed event that gets published whenever the routes get changed. But you can also have your gateway code reconfigure itself based on some arbitrary predicate by creating a refresh scoped bean. So we're going to create a bean that gets refreshed every single time there's an event. And we're going to use some external state. In this case, I'll just use a Boolean to tell us whether we should change the behavior of the route or not, right? But again, what you should take away from this is that you can talk to a database. You can reconfigure based on any kind of external stimuli you like. In this case, I'll just have a Boolean, right? So private final atomic Boolean WebSockets equals false, right? But maybe we want to change that. So I'm going to make this bean refresh scoped, and I'll create a bean of type route locator. Route locator builder rlb.routes.build, and we'll create routes. And I'm going to call this the customer's endpoint, and we'll say if not this dot ws.get, then return this. So ID, rs, and the predicate will of course just be /customers. And if it matches, we'll then send it to customers. And that'll be fine the first time. But let's say that we know that if this has already been configured once, we want to set it so that next time around it gets set as true. It's true next time, right? So if it's not true right now, this w set equals true, and then we return this. And then finally, going down here, we're going to create a new route that proxies and forwards to the WebSocket endpoint. And we can do that because, of course, Spring Cloud Gateway understands how to do HTTP as well as WebSockets. So fs.setPath ws customers, right? That's the path of the downstream service. So the first time it gets loaded, this will evaluate, right? And the gateway that we have will work with HTTP. The second time it gets loaded, the Boolean will be true, and then this will get evaluated. So we'll have a WebSocket endpoint the second time. In order to see this in action, we'll create a little static WebSocket application. Window .add event listener load const ws new WebSocket localhost 9999 / customers and ws.add event listener message console.log new message data. And we want to make sure that when there's an open socket, we can actually send out a request with it. So we'll say ws.send, and here we've got nothing to send really, so just, there we go. Let's go ahead and restart this application, this gateway code. Localhost ws.html. So this is failing at the moment. It's not working. Let's refresh the configuration. And there's the data. So in this section, we looked at how to create the route locators with the Java API manually. We looked at how to create routes with the YAML configuration format. We looked at how to externalize that configuration using the Spring Cloud config server. And then we looked at how to use the refresh scope to dynamically reconfigure our routes based on some external predicate, some external influencing factor. Of course, this is just a simple example, but the idea is that you have full control over how to consume and create these routes. There's also that routes event that we looked at earlier that you can use to respond to changes in those routes as well. In this section, we're going to talk about how to use Spring Cloud Gateway to introduce reliability to some of your downstream services. And there are many different things we can look at here, so we're going to limit our choices and we're going to review just a few things. Let's go back to our gateway code. I've copied and pasted the original basics module and I've gutted out most of it, and we've got it right here, right? So the few things that I've added to the class path include the Spring Cloud Starter circuit breaker for Resilience for J. The Resilience for J project is a third-party project that has, among other things, a really useful implementation of a circuit breaker. I've included the Spring Boot Starter Data Redis Reactive support so that we have something to store rate-limiting data into. And I've got the Spring Boot Starter Security dependency, and we're gonna see how all these plug in just a second. But otherwise, they are as we saw them before. So the first thing that we're going to look at is creating a gateway. Okay, and the gateway, as before, we'll use a route locator builder. And now what we're going to do is we're going to look at a few different filters here, right? The real power of Spring Cloud Gateways and all these filters. And you've seen some of them before. And by the way, did I mention that you can also use global filters? You can actually define a bean that gets plugged into all routes, right? Which is very convenient if you want to do that as well. So, but we're going to talk about route-specific filters here. So we're going to create a new route as always, and this is going to be pretty simple. Given a request called error, we want to send this down to the downstream service, the customer service, like so. And I'm going to create a new endpoint on that customer service in just a second here called error. And we want to retry that request if something should go wrong. Now, keep in mind, lots of things can go wrong, but we want to make sure that if something does go wrong, that we retry the request. Let's say it's just 5 times. Now, keep in mind, I've just shown you the abbreviated form of this particular filter. There are a good deal, many more options that we could have indulged in. So, for example, the retry config is an option, right? We can actually override the config itself, and there you can specify what exceptions to look at, how long we should take off before we try again, how many times we should retry, what status code we should be aware of, what exceptions we should respond to, etc. But there are sensible defaults for most of this, so I tend to just use the default and simplest filter, which is, how many times do you want to retry? And it'll, by default, I think it'll respond to status code 500 errors and so on, and any I/O exceptions, that kind of stuff. So any general kind of stuff, it'll do the right job. But you can customize it, of course. So let's go ahead and now that we've got our simple filter, let's go to the customer service and add that endpoint. So we're going to create a new class here just for this module. Reliability REST controller, and we're going to create a new endpoint here where we look at an ID, and we're going to return a response entity. So, and the reason we want this ID is so that we can, for our purposes, just to kind of see what's happening, we can keep track of who's making the request, right? I'm not going to bother with authentication or anything like that, but let's just store a count of how many times a request has been made to a particular path, and that path will be unique by its ID, right? So we can see how many times ID 1 or 2 or 3 or 4 has made a request. So here we go, error, path variable will be the ID there. And we're, pretty straightforwardly, right? We're going to create a little map here, private final map of string integer or atomic integer, counts of errors, okay? And it'll just be an in-memory database kind of thing, so there's that. Okay, so now we're going to need to compute an atomic integer based on each update. So this dot count of errors dot compute ID new by function, and we're going to say if null should equal atomic integer equals new atomic integer 0, right? That's 0. We want to take the atomic integer and increment it. I guess we just want to increment, yeah. And then we can just return this, okay? So now, if it's 0, then the value we should have at this point in the return value here is 1, right? Because we've incremented it. If it's 5, then we should have 6 in result, right? So there's the output. Now, we can use that to determine what kind of response to send back. If the result should be less than 5, then return response entity dot status HTTP status service unavailable dot build. All right. Dot get. Otherwise, return response entity dot OK map dot of message, and hello, or no, good job, you did it on try number, okay? And we'll just parameterize this a little bit, ID. All right, so pretty straightforward, yeah? We're creating a mock endpoint that will return errors. It'll return a 500 status code every single time for the first 5 requests, which is great because we're going to have 5 retries in our filter there. So let's go ahead and restart this. And go back to the gateway and try it out. So now, assuming we have a request to here and here, we should see it retried 5 times. Oh, I don't think we wrote out the logs, did we? So let's fix that here. System out error for ID on count. Okay. There, so we'll log this out. That way we can kind of see what's happening behind the scenes here. Success. Now, before we can start the gateway code, we need to comment out the security because it'll get in the way, just temporarily, of course. We want security. Security is good, but at the moment it's going to protect everything, which is a little overbearing since we're trying to get access to a certain endpoint and I haven't configured Spring Security. So we'll run the application, and now we can go to any endpoint we want on the gateway, unless, you know, assuming of course that you want to go to this one endpoint. So I'm going to type in, you know, Josh, whatever, okay? And you can see, good job, Josh, you did it on try number 5. So if you go to the customers endpoint, you can see that it's already very quickly gotten 4 other requests. Those failed, and then finally the 5th one was successful. It all happened in a blink of an eye, right? So that's a retry, and very, very powerful in of itself. You know, a lot of things are ephemeral in this world. Like, you might have a service that's temporarily unavailable. You might have something that's not online, in which case just retrying often does it, right? I mean, if you just ask anybody who does batch programming, retries are amazing. So very useful in of itself, and again, you can further customize this. I've just done 5. One of the very natural successive steps is to then configure back-off time, like duration in milliseconds of how long you want to wait before you retry again. Because if you have 5 retries that all kind of happen really quickly, like a thundering herd, all in lockstep, then you end up having a cascade where you might have other services that are also hitting the same error at the same time, and they're also retrying in lockstep with you, you know, as fast as possible. And so you end up causing enough traffic that you end up downing the service, which is trying to come back online. So it's good to have back off. The next thing that we're going to look at is a circuit breaker. A circuit breaker is a way to ensure some default behavior for the application should we not, for whatever reason, be able to connect to the downstream service. So in this case, we retried and eventually it resolved itself. But what if it doesn't? You know, what if something goes wrong and we can't fix it? Or what if we don't want to wait? We don't want to keep retrying. We just want to cut bait and run, right? We want to try something else. So we can do that easily with the circuit breaker filter. But in order to use it, you need to configure the circuit breaker dependency, and that's what we have this resilience for J circuit breaker in there for. So our circuit breaker will look like this. We're going to have an endpoint here, path/customers, and the URL will be load balanced to customers, and the filter that we're going to use is circuit breaker, and for the circuit breaker config, we're going to specify a fallback URL. So what's going to happen is it's going to attempt to do something, and if it fails, we'll tell it where to go instead. And the only kind of scheme that you can use, the only kind of URL is one that starts with forward. So it has to be to another endpoint on the gateway, and that's fine, right? So here we can just have a default endpoint, and here we can have a default endpoint, and that works just fine because it's very powerful, right? If something goes wrong, it loops back to the gateway, and the gateway gets another chance to try and handle the request. And you can create a default gateway path if you want. If you want to configure things like retries and fallback and all that stuff, you can actually configure the underlying resilience for J circuit breaker, and that'll be picked up by Spring Cloud Gateway's use of it here. So let's create another route here, a default route, rs.path/default. So when there's a request to /default, we're going to configure a filter. The filter will have just a generic filter. We'll just write one just to prove that it's happening. Chain.filter exchange. And we'll try it again. Okay, so there's our filter. And the other thing, of course, when we create a filter, we need to have a route. And so that route in this case will be to spring.io/guides. Okay, good. So there's our basic arrangement. Route, path, filters, URI. So we've got our default endpoint. This is going to forward to this default endpoint, which means that if there's any errors in the customer service, they should be redirected to the guides page. So let's confirm the happy path first. Let's make sure that our customer service is up. It's still there. Okay, so let's try it out. I'm going to restart the application. Go to the browser, localhost 99 customers. That's the happy path. That should be working just fine. Now what happens if we kill the downstream service, if we shut it down? Goodbye. Go to the browser. And here we expect to see guides. There you go. I hit the request, refreshed. It tried, it failed, and then redirected to the guides. So the circuit breaker is kind of like a more advanced retry. But a lot of times retry might be all you need. A circuit breaker can go one step further and give you a default fallback value, a fallback endpoint. The next thing that we care about is making sure that we don't overwhelm our downstream service for whatever reason. Maybe you've got some very expensive resource, or maybe you're just trying to make sure that people can't exceed the capacity you've given them. So we're going to use a rate limiter to make sure that only so many requests per second are allowed to trickle on through to the downstream service. In order to see this in action, just like with the retries earlier, we're going to create a little endpoint to kind of observe what's happening. So let's go to the customer's service again, and we'll add yet another reliability-centric endpoint here. And this time, we're going to see how many requests we get per second. So we'll keep a map, and the map will be to the current second and long, as a long, mapped to a count. So count per second. All right. And we'll create another endpoint, just calling it hello. It doesn't have to do anything in particular. We don't care about the response so much as we do the times it's been invoked. So we'll say return hello world, okay? And here we need to calculate what time it is right now. So we'll log that out. And then the second is now divided by 1,000, last I checked. Milliseconds being 1,000th of a second. And then we want to get the count for the current second. And we want to compute that relative to the map. So compute second, new by function. And again, same as before, we want to say, okay, if atomic integer should be null, then atomic integer equals new atomic integer, and atomic integer dot increment and get return atomic integer. Okay, so basic structure, basic arrangement of code, not a big deal. And finally, we can just print out the results. There have been requests for the second called second. Okay. Okay, so let's restart this. And let's go back to our gateway. And here, we're going to introduce the rate limiter. So we'll create a new route. Path will be to hello, because that's, after all, the name of the downstream service here. And I don't want to have to bother setting up the path. Not that it's a big deal. It's just, why bother if you don't have to? And LB customers. So assuming everything went perfectly, that would be enough, right? I'm just taking a path, forwarding it on to the downstream thing. But of course, we know the distributed systems world is never ideal. So we're going to use a rate limiter. And the rate limiter has its own little config. And basically, you have to provide a rate limiter itself, the implementation. And this interface is pluggable, of course, but there's already a very good implementation that's provided out of the box here for Redux. And so the idea is that, well, let's say I do, I don't know, let's say it's 5, and we want to burst to as much as 10. So that'll be our rate limiter. And this Redux rate limiter uses Redux behind the scenes to store an atomic number, to keep a count. And that means that even if we have 10 different instances of this gateway behind a load balancer, and they're all just sort of being randomly, round robin invoked, then we're still ensuring that at most so many requests get past our proxy, even if there's 5 instances of the proxy, right? Because we want to make sure that the downstream service doesn't get overwhelmed when there's too much traffic. The rate limiter will be consulting a count that's being kept in the Redux database, independent of any one Java virtual machine. So, it doesn't matter what node the request hits, it'll still be forced to stay within the bounds of the rate limiter. I'm using a nonsensically low number here so that we have a hope of being able to see it in action, but obviously you can and should expect a great deal more scalability and requests per second in your production code. So we'll plug that in. And the other thing that we need to do is we need to provide a key resolver. And the reason we do this is because behind the scenes, like I say, it's using Redux. So the contract here is pretty simple, right? You could just say mono.just my count. And what that'll do is it'll make it so that no matter who's making the request, no matter where they are in the world, they all have the same rate that we care about, right? So in effect, you're now only allowing a certain number of requests in total, in absolute total, to the downstream service. But that's not usually what people want. Usually what people want is to allow no more than so many requests for each user, because the problem isn't our absolute scale, right? Or at least it shouldn't be usually, especially today in the cloud-native world. We can spin up new virtual machines to respond to change and spin up new containers, etc. in Kubernetes. So it's not that we're trying to stop the total aggregate number of requests, right? Scaling out horizontally is not a problem these days. What we're trying to do is to stop any one user from overrunning the system, any bad actors. Most people are on the system doing the right thing, just trying to click around and buy things or do whatever they do on your system. But occasionally you might get somebody who's trying to denial of service your system or conduct entirely too many requests per second that would be inconsistent with a human being actually acting on the system. So here we can use a key resolver that takes the current principal from the request, takes the principal, gets the name out of the principal, and then returns that key, that string name, if it exists, and will return empty if it doesn't exist. So this is a very convenient thing, because by default, Spring Cloud Gateway it'll refuse to allow you to make a request if there's no key for you. And that key, of course, in this case, corresponds to a key in Redis. So we're going to set up we can set up a key resolver now to make the Redis key for the count based on the username. And so now each user gets so many requests per second, as opposed to the whole world gets so many requests per second. This is a very useful implementation. You can see it's pretty trivial to implement. It's so trivial, in fact, that we figured we just we give you a shorthand, and that's actually the principal key name resolver, and that does exactly the same thing as what I just wrote out long form does, right? Exchange, principal, flat map, whatever. Okay, that's one thing, one option. But keep in mind that that's actually also the default. So if you don't include it, you'll just get that as well, which is maybe that's all you need. But in order for that to work, of course, you need a principal, right? And this is where you need Spring Security. This is why we brought it into the build. Spring Security, well, we're going to have it sit there and block access to the downstream service unless they're authenticated. So in order to use that, we need to handle two concerns. One is authentication, and the other is authorization. Reload project. I'm going to create a hard-coded username and password, JLong in this case. This is a terrible idea in production, of course. You should take advantage of some of the more sophisticated security mechanisms that Spring has on offer, including but not limited to, OAuth. And by the way, while we don't have really enough time to show it in this particular video, one of the more interesting applications of Spring Cloud Gateway is to use it as a token relay. So you can have it forward authentication tokens from clients down to the downstream services. And so in that way, Spring Cloud Gateway ends up being your centralized, federated authentication mechanism. Okay, so one user with the username and password, hard-coded in the source code. Terrible idea. Again, don't do this in production. And then we need authorization, and that's just the question of what endpoints can, downstream components use. Okay. And then we have the discussion of authorization, which is really just a discussion of what endpoints can a client have access to once they're inside the system. So http.build, but we're going to comment out something. We're going to disable certain things and set up certain things. So ae.anyexchange permit all. We want to make sure that that one endpoint, the one we're trying to put behind the rate limiter, is secure. So hello, path matchers, hello, authenticated. All right. And finally, we want to say CSRF. I'm going to disable that. And then finally, we want to enable HTTP basic. Alrighty. So there's our basic security infrastructure. This is just an absolute hello world Spring Security application after all, nothing fancy. We got a Redis rate limiter. And if we understand everything correctly, we've got a rate limiter. It says it's going to allow so many requests to the downstream service, and we should be able to see those counts, those requests, reflected in the output of the service as we make those requests. So let's go ahead and restart the gateway, and we'll see what happens. So there's our endpoint, hello. Let's invoke it. So curl -u JLong pw http localhost 9999/hello, and there's the request, right? So that worked. We can see it in there's been one request for this in this 1 second. Now let's drive some traffic to it. So while true, do done. You can see it never gets above 10, right? That's our burst. So that's how you do a rate limiter. Pretty trivial, huh? Pretty easy. So now, with Spring Cloud Gateway and the reliability patterns, oops, you can see we're getting the errors because there's no more, it's not allowing me to, there's no downstream service, so it's failing there, and I didn't put any retry there. So now with Spring Cloud Gateway, we've looked at a number of different patterns to support reliability. We looked at retries, we looked at rate limiting, and we looked at circuit breakers. This is just the beginning, obviously. There's so many more that we could look at, but I think you got a good sense of what's possible.
Yeah, so
Spring Cloud Gateway is a phenomenal piece of open source technology that's designed to meet production use cases and scale at ease. Unfortunately, we don't get to have a very strong opinion in our Java source code about how you deploy this thing in production because we don't know what production is for you. We do have two products, two commercial offerings that might help you in two particular environments. First of all, we have Spring Cloud Gateway for Cloud Foundry, which you can use in a Cloud Foundry-centric environment using something like the Tanzu application service. And then we have the Spring Cloud Gateway for Kubernetes, which we've just released. The Spring Cloud Gateway offering for Kubernetes is a commercial product that's designed to help you operationalize Spring Cloud Gateway. To learn more about this, I wanted to talk to the amazing Chris Sterling, who's the lead of Spring Cloud Gateway for Kubernetes.
I think there's some use cases that are typical across many of the gateway implementations. So some of those are things like security. If I want to hook into for a single sign-on into an identity provider of my choice in the enterprise, maybe an Okta or Auth0 or something like that, then I can actually connect that in and have all of the filters and predicates that are associated with that in the commercial product. So, for instance, login. You should be able to automatically be redirected to login. Those aren't in the open source. You could add them in if you want to, but you'd have to create all of that for yourself with Spring Security. And we've kind of generalized it so it's easy to use. And then the other thing is we've actually packaged in some additional filters like client certificates for MTLS. You kind of get a lot of things out of the box. Rate limiting, we have session management if you do an HA configuration. That's something you really got to think about if you're creating your own gateway. I don't want to run just one instance. I probably want to run more than one so that I don't have downtime. That session management we actually do through an in-memory data grid. And some other things you have to think about. If you're deploying to a particular platform like Kubernetes, the operations aspect, so day two operations. What happens after you deploy it the first time? How do you do upgrades? How do you manage backwards compatibility? How do you do rollbacks? And how do you integrate with the platform? So see the logs, be able to describe events. We've done all that for you. So we actually have a Spring Cloud Gateway operator on Kubernetes that go ahead and interacts with the K8s API and is able to provide all that information for you, what's going on.
All right, Spring fans, I hope you got something out of that video. I hope you liked Spring Cloud Gateway as much as I do. Obviously, it's awesome, right? And there's a lot of really cool possibilities here. I hope you learned something. I hope you had fun along the way. Thank you so much for watching as always. You may have noticed, if you're a long-time watcher of the Spring Tips series, that things are a little different now. Things are getting bigger and better. And so I hope you'll stay tuned and join us for the adventure. Obviously, I am going to be here, and I hope you will be too. I am, as always, your host, Spring Developer Advocate Josh Long, and I hope you enjoy your journey to production.